Hi everyone. I'm wearing my futuristic headphones today. Today's lesson is on what is a quadratic equation. So I'm going to be going over what makes something a quadratic equation, unlike the linear equations we were solving earlier, and then how to identify whether something is quadratic or not. So a quadratic equation is one where you have an equation. It means you have an equal sign, and your highest exponent is 2. So these are also called second degree equations because they have degree 2 and they're polynomials. So because the highest exponent is 2, that's where the second degree comes from. And the highest exponent basically tells you how many solutions you can have. So because it has an exponent of 2, we have 2 solutions. Now, the word quadratic, if you're wondering, well, how does something with a degree 2 turn into the word quadratic, where quad usually means 4, it actually comes from the fact that quad doesn't actually necessarily mean 4, it means square. Square has 4 sides, but you have something that's x squared, that's where we get quadratic. So it comes from the fact that it's an x squared, not that it's degree 4. And this term actually didn't even come about until about the 1600s or so. So you can see that they use Latin, and then there's some other languages that have similar words as well, but it originally came from Latin. So we have what's called standard form of a quadratic equation, and this should look very familiar because it looks like what you see when you are factoring. The difference is that it's an equation, and in order to be in standard form, it has to be equal to 0. So that's what makes it a standard form of a quadratic equation, but you can have an equation that's not in standard form and still be quadratic. But the general rule is we want to have one side equal to 0. So there are other forms of quadratic equations that you can see. I have some listed below. This is not every possible combination that you can see or that you'll find, but these are all types of quadratic equations, and these are the most common ways that you'll see something that is quadratic. And essentially, they're all in the form ax squared plus bx plus c, except for the 2 bottom ones. Those are factored. But if you multiply it out, it will turn into one of the other forms that we have. So sometimes you see quadratic equations and they're factored, but they're still quadratic, they're just in a different form. So one of the things that you really need to be able to do is recognize, is an equation quadratic, is it not quadratic, because that tells you what you do. So if you're asked to solve an equation, you need to know what type of equation it is so you know what procedure to do. If it's linear, there's a certain step that you do. If it's quadratic, you do something else. So that's why it's important to know what type of equation it is, so that way you can go to your notes and say, okay, for this type, this is what we do to solve. So we're going to identify these equations as linear, quadratic, or other. So I've got 8 examples here. We're just going to do, let's just do the top, or the first column, and then we'll do the second column. So the first column, we have x squared plus 6x minus 7 equals 0. So what makes it quadratic is that your highest exponent is 2. So the highest exponent 2 is 2 there. That's what makes it a quadratic equation. So this is quadratic, and this is actually in standard form. Now the next one below it, and sorry about my dog barking, she's very unhappy. I'm sure the mic is picking it up. The next one below it, we have x cubed minus 8x squared minus 20x equals 0. So you look for the highest exponent, and that is 3. So it's not 2, so this is not quadratic. So we know it's not quadratic, it's either linear or other. Linear equations don't have exponents on their variables. So it's not linear, so this is other. Now, the third one in the first column, we have 3z times 2z plus 4 equals -7. So to determine basically what this is, you can look at what you're multiplying together. We have a 3z, and we're multiplying it by something that's 2z. A z times a z gives you a z squared. So we're going to get a z squared out of here when we multiply, which makes this quadratic, because that will end up being the highest exponent. And this is actually like this form right here. It's just instead of being equal to 0, it's equal to a number. So this is quadratic. And you can multiply it out, and you'll see that. You can distribute and simplify the left side, and you can put it in standard form. Bottom here, we have 4s squared equals 64. Highest exponent on the variable is 2. That makes this quadratic. Now let's look at the top right. We have a squared minus 64 equals 0. So our highest exponent is 2, so that's quadratic. This is one of the forms that I have here. This is actually the same as this form right here, where we have an x squared plus something, or in our case, minus something. Okay, now on the bottom, second one on the right column, we have 2s squared minus 6s plus rs minus 3r equals 0. So this is quadratic. Even though we have more than one variable, it is still considered quadratic. Now, you guys are never really going to solve things like this with more than one variable, but it is still considered quadratic because the highest exponent is 2. And if you look at the rs portions, if you combine those, that would be considered to have an exponent of 2 if they were the same variable. So this is quadratic. It's just a very interesting looking one. And we could factor that by grouping, which is something that you'll learn. Actually, you already know factoring by grouping. So we can factor that by grouping, and then there is a method to solve that, though you're not really going to be asked to solve things like that one. Okay, now underneath it, we have 5 times 2x minus 3 minus 2 times 3x plus 1 equals 4 minus 3x. So we have 5, which is a number. There's no variable there, times something with an x. So that's just an x. And if you get just something with an x, that's a 1, an exponent of 1. And then we've got this minus 2 times something with an x. Something with no x times an x is just an x. So our highest exponent we're going to get out of here is 1. If you multiply it out, add all of your like terms, your highest exponent you're ever going to see in the x is 1. So that makes this linear. So you'll want to note the difference from here to the one to the left, where it was quadratic because there was a z in front of the parentheses. This is linear because there is not the variable in front of the parentheses. Now the bottom example that I have here, we have x minus 3 times x plus 4. If you ignore the numbers, you get x times x. That gives you an x squared. It doesn't matter that it's equal to 6. What matters is what we have with the x's. We're going to get an x squared out of here, and so this is quadratic. And this one is basically the factored form of a quadratic. It's very similar to this last one right here. It's just instead of equal to 0, it is equal to a number. So most of these examples here are quadratic. I wanted to give you a wide variety of what they could look like so that you can understand, okay, I need to know what type of equation this is because that tells me what to do. So why are you guys learning about quadratic equations? You know, what is the point of this? Well, it actually shows up a lot in real life with geometry. So the Pythagorean theorem actually is a quadratic equation. There are a lot of different types of problems that you can do involving area, and they can be different shapes. Circles, rectangles, squares, triangles. Area is always something squared, which lends itself to a quadratic equation. And one common use of these type of problems is if you know you need to make something that's a certain square footage, and you know the size of one length, you need to figure out your missing length. You know, if you're going to have two sides, like a rectangle, length times width is area. So sometimes or you know that, okay, this has to be 2 times longer than the other side, or you have some, you know, restrictions on the shape of what you're building, you can have a quadratic equation. The Pythagorean theorem part is actually really important. I had somebody who was working on the roof, and they needed to get a certain angle, and they ended up having to do the Pythagorean theorem, and they were trying to do the math, and they came to me to make sure that they were doing their algebra correctly. So yes, this does show up in real life. Quadratic equations show up a lot in physics and electronics. So, and electronics is actually a part of physics. So there's generally, when you take physics classes, there's kinematics, which is like distance, velocity, speed kind of physics, friction, like the physical stuff. And then there's, that's called kinematics and mechanics. And then the second one is like electricity, magnetism. It's the unseen parts of physics, like the non-physical things. So anything electronic is actually basically applied physics. So that's why those are in the same category. So vertical distance, if you drop something and it has to follow gravity, that is actually modeled with a quadratic equation. And projectiles, if you are throwing a baseball, or you hit a baseball with a baseball bat, you're throwing a football, you're shooting something out of a cannon, you're shooting a gun, you know, a bullet, anything that's considered a projectile is also following a quadratic equation. Resistors in parallel. If you have resistors in parallel, you know the total resistance. You're trying to find what the actual resistors are equal to. That gives you a quadratic equation. Equations for power often have squares in them, and so that comes up with quadratic equations. There's even there's a root mean square that you end up having to create a quadratic equation in order to solve. You have to kind of undo it. Other uses are arches. So you'll learn about this later in the class when you graph quadratic equations, but they actually form an arch. So anything that's an arch, in order to make sure you have the right shape, you actually have to make a quadratic equation. Equations for profit from supply and demand. So usually what happens is, as supply increases, like, so you've got your curves, and if something's rare, your demand is high, so you're going to make a lot of money, and then you're going to kind of even out, and then as something gets, you know, you have all these different shapes, and there are often, when you're trying to write equations for supply and demand, and then you're trying to figure out profit, they often come out actually to quadratics, where you end up with like a curve, or usually where the demand is high, it goes low, and then it goes high again, or it might be the other way around. So those are actually often quadratic. There are some situations where you're solving things with distance, rate, and time that actually end up quadratic. Those are the types of situations where you don't know your speed, but you know you're faster in one direction or slower in the other direction, like if you're running with wind and against wind, but you don't know how fast the wind is. If you're trying to figure out your speed and the wind speed, that's one situation where it would end up being quadratic. Satellite dishes and other kinds of curves, the way that the curves are actually are quadratic equations. Like if you make a cross section of it, so it's kind of like a bowl, those are quadratic. And anything that kind of has that sort of shape. So if you have lenses, I don't know if you have glasses, but they're not flat, they're actually slightly curved. So those are with quadratic equations. There are mirrors that are slightly curved, and those are quadratics. Telescopes use curved lenses, so that is also use quadratic equations. So these actually show up quite a bit, which is why it's one of the things you're learning about in fundamentals of algebra, because it does show up so often in real life. So that was my what I wanted to go over today, was to talk about what a quadratic equation is, how you can recognize it, and then where it's used. And then from here, you're going to want to go to one of the other videos on learning how to solve these things. I would definitely start with solving by using the zero factor property. So basically you factor and then you solve. That is one of the easiest ways. So hopefully this was helpful, and I will talk to you guys later. Bye.